Welcome to Narayan Microwave Technologies.
In this video, we are going to see the working of our trainer, which is 5 application trainer. Model number of this trainer is KMS-613. This trainer comes with various experiments you can perform. The experiments such as a stable multivibrator, bistable multivibrator, monostable multivibrator, sawtooth generator by using the IC555 IC. And some other components are also available on our trainer board. We will see when we perform the experiments how to use this component. So first, let's perform one of the multivibrator, which is monostable multivibrator, which is also called as one-shot multivibrator. So first, let's make the connection. Connect this T10 to this T2, then connect this T5 to this T7. That means pin number 7 and 6 are shorted. Connect this T8 that's shorted of 6 and 7 pin will be given to this T24, which is 1 microfarad capacitor, and connect this T6 to the T20, which is one of the terminal of 1 mega ohm or pot, and connect this T21 T4. Now then, let's turn on the trainer board by using the on-off switch, which is given at the rear end of our trainer board. Okay. After making the turning on the kit, we have to check the status of LED. Here we have used this R and C. So these are the RC component. If I press this switch, you can see the LED is on momentarily because the R value is quite less. If I increase the R value using this potentiometer and then pressing the switch, you can cleanly check the on status of LED has increased. If I increase the potentiometer further, you can check the on status of LED has increased furthermore. If I increase it further, so you can check the status of LED. So this time constant can be calculated by using R and C component, or you can calculate the period of our LED on off condition by using the formula. So similarly, you can change this capacitor of 1 microfarad to 10 microfarad, and you can perform the same experiment. If I increase it, it will be remain on a little longer compared to the 1 microfarad. Or the same potentiometer, if you give the 1 microfarad, and you can check the on status is quite less. So depending upon your RNC value or on off period of LED will change. So this is for monostable. Now let's perform the stable multivibrator, which is also known as free running multivibrator. For a stable multivibrator, connect this T6 to T4, connect T5, this is our T5 to T20, this is R value, connect this T8 to T24, this is for C value, connect T21 to T2, and connect T2 to T7. So these are the connections for our stable multivibrator. One more thing you can do is to first let's observe the output of our multivibrator. When this potentiometer is at minimum position, you can see the LED is remain on position. Now if I rotate this a little, you can see there is a change in the status of LED. As we keep on rotating or increasing the R value, our frequency of LED turn and turn off is getting lesser. The same waveform you can observe on the oscilloscope. To check the result at the oscilloscope, let's connect the channel 1 of our oscilloscope, the positive terminal, to T1, and this ground terminal you can connect to the ground terminal. You can observe the waveform of our C. There's a frequency is higher, so the frequency of this LED on and off you can observe on the oscilloscope, which is nearby 100 Hz. If I change this potentiometer, the frequency is also changing. You can check it on the LED. So you can take the reading such a way that take the reading that on off period when the potentiometer is at minimum position, and check the frequency of our on and off period when your potentiometer is at maximum position. At present, it is nearby 757 millihertz, which is less than the 1 hertz. So this is for your stable multivibrator. Now let's perform the third multivibrator, which is bistable multivibrator. So let's make the connection for bistable multivibrator. Before that, let's remove all the connections. For bistable connection, let's connect T11 to T2, T11 to T2, T7 to T22. This is T7 and this is T22. T25, here it is T25 to T8. This is our multivibrator, which is bistable multivibrator. Now let's turn on it to check the output of our multi-vibrator, which is bistable multi-vibrator. You can check this is the LED status of output LED status of bistable multi-vibrator. It will remain on until we will apply the pulse. So by using this pulse, your status or LED status will change. Means here our 5 is working as a bistable multivibrator. That is, it works in the both states of output which are stable, and it will change only by giving the pulses. So this is the working for bistable multivibrator. One more experiment you can perform on the kit, which is sawtooth generator by using the IC555. So let's perform the experiment of sawtooth generator. So performing that, let's turn off the kit, connect this T5 to T7, T7 to T2, T8 to T24, T12 to T20, T25 to T21. Okay, now let's observe the sawtooth which is generated at pin that output of IC555, which is at pin number 2 or terminal number T2. Let's turn on the kit. One more connection we have to give, which is connect T14 to T6. At the output at T2, you will be having the sawtooth. The frequency of sawtooth can be controlled by using this R value, which is given by potentiometer. So you can check the frequency of sawtooth. And you can also replace this 1 microfarad with 10 microfarad. The moment you change the capacitor, the frequency of sawtooth will also reduce. By using the 10 microfarad, we are having frequency of about 11 hertz. While using the 1 microfarad of capacitor, we are having the frequency of about 100 hertz. So these are the experiments you can perform on the single kit. Thank you for watching the video.